IP address. So look, we did that correctly. Now let's go ahead and add the 192.168.4, run it. And you can see, okay, it's sweeping, but it's taking its sweet time. Especially for the IP addresses that are gonna hang, like if I don't have a .2 or .3, it's gonna take a while. So I'm gonna Control C and get out of this if it'll let me, and it looks like it's actually gonna hang. So what we can do is we can come back in. I'm gonna open a new tab real quick just while that's waiting. And I'm just gonna say mousepad, and we're just going to go back into ipsweep.sh. It's in this folder. There we go. Okay. So from here, I'm gonna change this back to the ampersand, and I'm gonna save it. I just want you to see the difference really quick and why I run it like this. So ipsweep.sh 192.168.4. You can see it's picking everything up really fast. All right. What I can do now is I can run this and then store this into like ips.txt, something like that. Just like found IP addresses. Okay, so now if I cat ips.txt, I have all the IP addresses I just found, and I found them that fast versus this, which may still be going, and it is, and I can't even kill it. I'm just gonna close this out. Okay, so this is the big difference there with that ampersand and the speed of what it is capable of doing. So with all that being said, we could take this and do one more thing. So I wanna show you how we can utilize a one-liner. These are called one-line statements in Bash, and we can do similar to what we just did and accomplish that in this command line. So now we have an IP address. We have a list of IP addresses. Let's say that we want to run nmap. Now we haven't gotten to nmap yet. You don't need to really know about it. Just know that it is a tool that allows us to go out and do port scanning. Okay, so typically we would just say something like nmap, and we might do something like dash T4 dash A dash P dash, like this. This is just saying, I wanna run nmap scan, I wanna look at everything, and I wanna scan all ports. This is just an example. You can just run nmap IP address like this, and that would be fine too. Like we could just go 192.168.4.29, and we'll do a quick nmap scan. Okay, but what we can't do here is we can't just say, hey, I want to run, well, we could say, I want to run nmap for everything in .0/24. The issue is it's going to take time looking and finding what IP addresses are valid here. If we have a list, we can automate this process quite a bit. We can just come in here and we can say something a little bit different. We can say, hey, for IP, we're using the same kind of syntax, in $, and we're gonna put parentheses here, we're gonna say cat, and then we're gonna say ips.txt, and then we're just gonna do this. We're gonna say do nmap $IP, and then again, we have the option of doing done, or we can do ampersand done, just like this, okay? I'm just gonna do done here as an example and just show you. So this is really easy. We're saying, hey, for every IP address in this list, and all we're doing is we're catting out this IP list that we just had. So it's gonna take the first IP, then run the nmap scan, and it's gonna come back and run the next one. So until this list is completely done, it's gonna keep going through this loop. That's all it is, a simple loop. And then we're gonna say done. It's gonna take that IP address, it's gonna start scanning it, it's gonna go through and hopefully find information and go in a loop. So this is a quick way to automate some of this process. I actually do this with a lot of my scripts where I will do some probing, see if anything is out there that's alive, put it into an IP file, and you're gonna see this later in the course, and then nmap scan that. So think about this. Hopefully this gets your wheels spinning on what you can do to really start scripting some of this stuff out. And this is gonna be the first time you get your hands dirty with scripting. We're gonna go on again with this, and we're gonna get more advanced as we go. But this should be a good introductory lesson to you on how we can build a simple tool and automate a lot of this process fairly easily with just a little bit of command line syntax. So we're gonna go ahead and move on to the next section, and I will see you over there. Welcome to this module on Python. So if you've never used Python before or even heard of Python before, Python is a coding and scripting language. It is commonly used in ethical hacking, and it's commonly used all around the world.
it is actually considered one of the best beginner languages to start with if you've never learned coding before. So that's exactly what we're going to do. We're going to cover some of the basics of Python. So we'll cover everything you see on this screen here: strings, math, functions. We're going to get into conditional statements and looping. We'll get into some more advanced items, and eventually we're going to build our own tools. So we're going to be building a port scanner at the end of the lesson. And then when we get into the exploit development section of this course, we're going to use Python again to write our own exploits. So it's going to be used throughout the course. You're going to see it again as a ethical hacker as well. You're going to go onto websites and you might need to download Python code or something to utilize against a host or a client, and it's just going to be frequently seen for you. So very important topic to cover, especially for the foundations. One very big thing to point out: you do not have to be a developer to be successful in penetration testing. The important thing is that you understand what you're seeing and understand how to read code. If when you come away from this module, you have a better understanding on how to read what you are seeing in code, you'll be much better off. By no means do you have to be a developer. I am still to this day nowhere near a developer level, and I'm very, very successful in what I do. You don't have to be a developer. So the big takeaway here is to take very good notes, understand what you're seeing. If you need to watch a video multiple times in this section, absolutely okay. Just make sure you understand everything in front of you and understand that the lessons are going to build upon each other, and it should all come together in the end. And you're going to get to see it over and over through the course, especially in the exploit development section where we write our own Python script. So I look forward to teaching you this module on Python and look forward to seeing you in the next video. Welcome to your first video on Python. So in this Python series, we're going to cover a lot of different topics, and we're just going to build upon them slowly so that everything builds kind of upon the last lesson. So in this first lesson, we're going to be talking about strings, and we're going to be working primarily in Python 3. So quick thing to note is that my Kali interface might look a little bit different. I'm on my personal pen test machine here. The only reason I'm doing that is because when we get into the text editor, my text editor on the newer version of Kali would not let me edit my preferences very easily. So I went ahead and just went back to my machine that has an older text editor on it. So you can follow along completely step by step in your Kali and you should be fine. I just wanted to make sure that the font size is good enough for the recording. So from here, let's go ahead and make a new directory. And I'm just going to call this directory Python. And then we're going to change directory into Python. And the first thing we're going to do is we're going to gedit. And I'm just going to call this first.py. This will be our first Python script, and we're going to build on it. So the first thing we need to do is declare what it's called a shebang. So that is a hash bang like this. And we're just going to declare bin python3 here at the top. Now, what does this do? This allows us to know, or the Linux to know when we run this. Say we were to run this like Python 3, and then we just say first.py. If we run it like this, then Python interprets the hash here, which you're going to learn in a little bit, as a comment. So all of this is commented out. We don't have to worry about it. But let's say we wanted to run this a different way. We wanted to say ./first.py. Then it would actually be interpreted here at the top. So Linux would go in here, it would read this, it would say, hey, this, I'm going to go ahead and look for bin python3. It's going to find python3 in bin because that's where it's stored. And then it's going to use that to execute Python, or this Python script here. So we have two ways of running it. We could either run it python3 first.py, or we can run it as you've seen it with some of our other scripts with the / like this. So I always like to declare at the top. It's not necessary if you're just going to type in python3, but I always like to do it. So I'm going to give you some headers here. So I'm just going to put a comment in, and we're just going to say print string. And so the first thing we're going to do is print a string. Now, in the very stereotypical lesson, The very first string that most people print is the hello world. So we're going to go ahead and just do that. So let's go ahead and print hello world. And we're going to do that by just typing in print. And then in parentheses with quotation, we're going to say hello world. Something like this. Okay. And that's it. So what we can do here is we can just save this. And we can go ahead and give this a go. So what we'll do is we'll say Python 3, and then we could say first, and it'll auto tab out to first.py. And you can see now that it wrote out hello world. So if we go tab up twice and go back to our gedit, we could see here that it ignored printing out anything here with the comment. It didn't interpret this because this is a comment with the hash. And we just told it one instruction, which was to print hello world, and it did just that. So the nice thing about strings is we could use double quotes, or we could use single quotes. So we could say, hello world like this. And we can also use multi-line strings. So I'm going to tab or hit enter twice here, and we could say something along the lines of print. And what if we have like a long quote? We could say something like, this string runs, and then we could say multiple lines, like this. And we just put that with triple quotations like this. And lastly, we can do a little bit of what is called concatenation. We could say something like print this string is, and then we'll want to put a space at the end here and end the quotation. Then we could put a plus sign in here, and we could say something like awesome and end that parentheses. So with all of this, you're going to see that, okay, we can print hello world. It should print hello world. This string runs multiple lines, and this string is awesome. And it should be space awesome here because we included the space. Now you're going to notice, even though we put line breaks in for us, no line breaks are going to be printed. We'll talk about that here in 1 second. So let's save this and let's just run it. So we're going to go ahead and run Python 3 first.py, and everything looks as anticipated, right? So I want to show you one thing. Let's tab up twice, and let's put an ampersand at the end of this. Watch what this does. Now, we have access not only to our script here, but we can also run code as well. So as long as we save this, we can run the code, and we don't have to keep exiting out back and forth. So let's say that we did want to put a line in between these two hello worlds. We've got this here. What we can do is we can print this. Can say something like a N like this, if I could type today, and we close this off. And you could put a little note next to it so you remember, and just say new line. So when you have that \n, that prints out a new line. So let's say that and just take a look at that. And there you go, you have a new line put in there. So quick and easy way to add a line in or a line break. And yeah, so here, very simple lesson, right? All we're doing is just learning how to print things, and we're dealing with strings. So even if you want to go in and build upon this, you can add comments in for yourself to make this easier. So you can come in here and say double quotes, you could say single quotes, and then you can come in here and say triple quote for multi-line. Right? And this way, you know kind of what everything is doing. This one you can say here, you could say, we can also concatenate. I don't know if you spelled that correctly, but I'm hoping I did. So that's really it for this lesson. Just want to cover the basics. So in the next lesson, we're going to start talking about math and the math that Python can do. And again, we're just going to continue to build upon this. So I'll catch you over in the next lesson. All right, let's talk math. So the nice thing about Python is that right off the bat, it has a built-in math interpreter. So what we can use it for is addition, subtraction, multiplication, division, etc. We could throw numbers at it and it'll do calculations for us. So let's take a look at what that actually looks like. So I'm going to go ahead and gedit. We'll call this math.py. You can call this whatever you'd like, by the way. I'm going to put the ampersand at the end again. And we'll just declare our bin Python 3 here. And then let's just call this math. So the nice thing about math is we can do a lot of different things. We're very flexible. So for example, we can print 50 plus 50. And here we're just adding, right? So let's take a look at what this looks like. We go here and we just say Python 3 math.py. You can see that it prints out 100. Now we can keep doing this for all sorts of different things, right? We can do 50 minus 50. We would expect 0 here, right? And we can do print 50 times 50. And we can also do print 50 divided by 50 and divide. So I'm going to give you a chance to catch up here. I typed that very fast. I also have notes that I'm looking at, so a little bit of unfair advantage. But so when we see these and we save this and we run it, we're expecting everything to interpret just the way it did. So you see 100, 0, 2500, and then this 1.0, which we'll get into in just a little bit as to why it's coming out in a 1.0 format. But so we have this here, and we can also do some interesting things, like let's do something fun. Let's do print 50 plus 50 minus 50 times 50 and divide by 50. And what do you think this is going to do? Our good old friend of PEMDAS, if you remember that from math class. So try it one more time, see what number it pops out. Pops out 50. So it also does more complex equations as well. So there's a few other things that I want to show you in the math section. And another thing to note, I know I've already stressed this before and I'm going to keep stressing it, is to make sure you take good notes. This is absolutely going to feel overwhelming. I'm going to throw a lot of things at you, especially with all the stuff that you're learning. Take good notes. Have a good notebook and make sure you're writing this all down, so then you can just go back and you can reference it. And from here on out, the next video, what we're going to do is we're going to make a script and we're just going to build upon it, and I'll just leave everything in that script so that way you kind of have a place for all of your notes as well. So here, let's talk a couple more things. So we can also do exponents. So let's say we want to do 50 to the 50th power. Well, we just write it like this. And now we have exponents here. Save it, run it really quick. And we get this very, very, very large number, right? We could just make this to the second power and make it a little bit simpler. We could also do this. So we do print and we do 50% 6. Now this is called a modulo. Let's take a look at what it does. So 50 is not divisible by 6, right? So what it does is it takes the number that is left over. So we do 50 divisible by 6. Okay, 6 goes into it 8 times, and then it has a leftover number of 2, right? 6 times 8 is 48. Leftover number of 2. So that's the modulo. What if we were to divide by a number here, and we said 50 divided by 6? What is that going to do to us? Well, we print that out, and you see it gives 8.33334. Perfect, that's fine. What if we just want a number without any leftovers? Well, we can do something like this. We can do 50 divided by 6, and then we'll just say no leftovers here. Okay, so I'm going to give you a second to catch up. We'll hit save on this. And we're going to go ahead and run it. And you can see that it just gives us the 8 doesn't give us that leftover of 2 that we had and put it into fraction form here, or decimal form here. So we have different ways that we can manipulate these numbers, and we can do math on the fly. There's also math modules, which we haven't gotten to the modules yet, but there are additional math items that we can pull into this, like bringing in random numbers, for example, and other things that we can do, more advanced calculations in Python. But as a base, it does quite a bit of items for us, and it is essentially a built-in calculator, so we can do quick math on the fly if we need to. So let's go ahead, and from here, we're going to move on to the next video where we're going to start talking about variables and methods. All right, so let's talk about variables and methods. So to do this, we're going to make a new file. So let's do gedit, and we're going to call this one script.py, because in the last video I told you we're just going to start building off of these scripts, and we're just going to keep it in one script and keep it going. So let's gedit script.py. We'll do one more shebang here of bin python 3, and then we're going to go ahead and just build this out. I'm going to drag this over just a little bit. So let's put another comment up here, and we'll just call this variables and methods. And let's define a variable. So let me show you what a variable looks like, and then we'll define what a variable really is. So let's start with a quote, and you can pick your favorite quote here, and we're just going to say something like, "All is fair in love and war." Okay, so what's happening here is we are creating a variable of quote. Now, a variable, all you can think of a variable is as a placeholder. So instead of typing out "all is fair in love and war," we can just call this placeholder at a later time, and it knows, hey, I'm going to call this information. So it's going to store this information inside of quote, and then later we just call quote, and it'll print it out. So we can do something like print quote and save this, and I forgot to ampersand, so excuse me, we're going to close it, and let's just run script.py, sorry, python 3 script.py. You can see it says all is fair in love and war. So if we gedit this and add the ampersand now, so we defined what was in our variable here, which was this string, right? We've talked about strings. We put a string here as our quote, and we printed the quote. So if we didn't put the print in here, we can copy this and just delete it. If we save this and we go to print this now, there's nothing telling this to print. So we have quote, and we have a quote stored in our quote variable, but nothing instructing it to print. So we can leave the print back in there, just copy and paste it back, and now it'll print that quote. Now, we also have what are called methods. Okay, so methods are basically functions that are available for a given object. Okay, so don't worry too much about that description. That's very dictionary-based description. Just think about what a method does. So I'll show you these methods here. So a method might look something like print quote, and then let's say we want to make quote upper. So in order to make it uppercase, all uppercase, we're just going to throw in this method of upper. So we just say dot upper. And if we were to save that and print it, look, now the text is all uppercase. And you can make a note in here if you want and just say makes it uppercase. And we can copy this. Let's just copy this whole line like this. And let's paste a couple here. So we could also do something like lower for lowercase. Or we can do something like title for title case. And we can make notes here of lowercase and title case. Okay, and we save that. And when you print it, what do you think is going to happen here? So we're going to say, all is fair in love and war, all is fair in love and war. And you can see in title case, not perfect. It's capitalizing the and here and the in and the is. But it does capitalize every first letter as it's instructed to do here. So these are methods. There's also other things that we can do. We can do something like, say we want to get the length of this quote. We want to know how many characters are inside the quote. We can do something like print length of quote. Okay, and we can just say save, and let's see what it prints out. Okay, so 28. Now it's 28 characters completely. If we were to count this all up, including the spaces, there's 28 characters there. So let's make this a little bit more interesting, and let's talk a little bit more about math and bring that into it and try to tie this all together with what we've learned so far. So let's use your name. Let's define a variable of your name, and we're going to set it as a string. So my name is Heath. So we'll just say this is a string, right? And let's also define your age. Now I'm 30. And we'll say this is what is called an int, or an integer. Okay, and let's say, what's your grade point average? And my grade point average was 3.7. And this is what is called a float. Now, what is the difference between an integer and a float? Well, an integer has no decimal point. A float does. So if I was 30 years and 27 days, I might be 30.1 years old, right? But if I only define as an integer, if I say int 30, then that's going to define that this number is an integer and nothing else. Same thing with float. If we want to have the decimal point there, we can float a number and define it as like 3.7. So let's make more sense of this. We can print out the integer of my age, and we can also print out the integer of my, or we could say 30.1, and let's see what happens as we discussed here. So let's save this, and let's just print out those two. And look, it takes 30.1 and makes it 30, and it takes integer of age and makes it 30 as well. Now what if this is 30.9? What do you think is going to happen? Do you think it's going to round? It in fact does not round. So you could see 30.9 still came out to 30 down here. It doesn't matter, it just takes this first number when we call an integer. So make sure that if you ever use integer, you know that it does not round. So let's build upon this again. We could take a string now, and let's print out a string. We could say something like, my name is, and then you could say plus name. Make sure you add the space in there, right? And you can also say space, and I am space. And then let's define an age. So if we try to put age in here, watch what happens. So we're going to say age, and we'll say space years old. And let's save this here like this, and I'll give you a second to catch up. So again, we're adding a space in the beginning, space at the end here, just so that we have the syntax right, or else it's going to all bunch up together. So let's try to print this out. And you could see cannot concatenate a string, not integer to string. So this age here is sitting here as an integer. You can't concatenate a string with an integer. So how do we fix that? Well, what we can do here is we can actually put this into a string format. So we'll just say string of age, something like this, and save it, and now it makes it to a string. So similar as we made something into an integer, and how we can make something into a float, we can also make something into a string. So if we come through here, and we hit enter, you can see now that it works. My name is Heath, and I am 30 years old. So a couple more things to note. What if we had something like our age, and we got a year older? Well, we can just say something like age plus equals 1. And we could say print our age. Now watch what happens. Age is now 31. Even up until that point, age has been 30, right? You see age coming through here. We're utilizing it in all three places. Now we print age down here and it's 31 because we have changed what is stored in the variable. So again, the variable here of age, we had 30 stored in it. Up until the instruction is called to add 1 plus equals 1, so we're just adding 1 to this age variable here, then it stays 30. Now it is 31 until we change it again. So we can also do something along the lines of birthday equals 1. So we have a value of birthday. And then we could say age plus equals birthday. And then you're going to print your age again. And guess how old we're going to be? We are going to be 32. So it doesn't matter how you store it. You can do the plus equals here or minus equals if you wanted to take away. And you can start incorporating your math into your variables. You can incorporate your variables into your strings, and you can start tying this all together. So if you need to rewatch this and to make more sense of it, that's absolutely fine. I'm going to harp one more time on this. Take good notes. Practice, practice, practice. This is stuff that can get overwhelming very quick, but hopefully I'm explaining it slow enough and you're getting it. If you're not getting it, please do rewatch the video, please take notes, and please utilize outside resources as well. I understand that I might not always be the best at teaching a particular subject, or sometimes it takes another person hearing it again from somebody else to see this. Coding is not necessarily easy, but once it clicks, and a lot of it is just repetition. So that is it for this video. We've started to tie everything together. Now from here, we're going to move into what are called functions and build upon all of this. So I'll catch you over in the next video on functions. All right, let's talk about functions. Now, functions are what I like to think of as mini programs. It's like this organized block of code that you define, and then you can call it later, and it makes it a lot simpler than typing everything out. So it's a lot easier to visualize this than me to just talk the theory of it. So let's go ahead and let's gedit our script again, our script.py, and then we're going to ampersand this one this time. And we should have our Python script from before. I'm just going to scroll down to the bottom, and I'm going to add in a new section here, and that section is just going to be called functions. So if we want to print out, we could print out a new line to kind of put this together. And then maybe when it's all said and done, we can print a function or make a function that just prints and make it a little bit easier for us. So we're going to print a new line here, define functions, and maybe we'll just print out something that says, here is an example function. So this is really just going to define the area. If we save it, while you're typing yours, I'm just going to print mine. So we'll Python 3 script.py, and you see we've got the new line here, and we see here is an example function, and we just start from here. So let's take a look at a function using something that we've already done before. So we've got this section here, and we've got name, age, GPA. We're going to kind of reuse this and this print my name is. So let's go ahead and reuse this. We're going to say function here, right? So we're going to define kind of a who am I. So we're going to define this, and then we're going to do 2 parentheses and then a colon here. So it's going to look like this. And what's important